Hello, guys. My name is Akshay Ravichandran, and I'm a volunteer for the Teen Advisory Board for the Howard County Library System. Today, I'm going to introduce you guys to limits. So let's begin by asking the question, what is a limit? A limit tells us the value of a specific function approaching when it gets closer and closer to some number. Limits are the basis of all calculus. To find a limit, we can either plug in the value, use a graph, use algebra, or identities. Keep in mind that limits only occur when the left-hand side of a constant approaches the same value as the right-hand side. So let's begin by practicing. Our first question, we have limit as x approaches 4 of the function x plus 4. So as I stated in the previous slide, all you pretty much have to do is plug in this value for x, which is 4, plus 4, which is 8. We can also see this in the graph. Let me just graph this function real quick. So it'll look something like this 4. And let's just say 4 is about here. This point is going to be 4, 8. So as x approaches 4 as x approaches 4, as this function approaches 4, this value is going to be 8. And that's the limit. For the next one, limit as x approaches 3 of the function x squared plus 2x plus 2. Just like the last one, we're just going to plug it in. So 3 squared plus 2 times 3 plus 2. You're just going to add these numbers up. 9 plus 6 plus 2. This gives us 17. So that's the limit of this function when x approaches 3. For this next function, limit as x approaches 5 of the function 6. If we graph this function, we know that it's going to be a constant. Let's just say this is 6. So we know that this function is going to be something like this. So no matter what x approaches to, the value is always going to be 6. So we know that the limit as x approaches 5, no matter what, will be 6. And that's the constant value. For this last one, limit as x approaches 1 of the function x squared minus 1 over x minus 1. We can't plug in 1 because that will get us a denominator of 0, which means the function would be undefined. So what we're going to do is what I said in the previous slide, and that's to factor. We're going to factor this out using one of our identities, a squared minus b squared, which factors out to x plus 1 times x minus 1. And then our denominator stays the same. So since we're multiplying each of these terms, we can cancel these out, leading us to x plus 1. And now we plug in the value. Now we can plug in the value as limit x approaches 1. X is going to be 1, so 1 plus 1 is 2, and that is our limit. All right, let's practice some more. For this next one, limit as x approaches 2 of the function x squared minus 3x plus 2 over x squared minus 4. Same thing here. You can't put 2 in the denominator, otherwise you'll get a denominator of 0, which means the function will be undefined. So we're going to factor this out. So x minus 2 or simple factoring laws times x minus 1, and then x minus 2 times x plus 2. Make sure you know how to factor. All right, we can cancel these out. The x minus 2's leading us to x minus 1, x plus 2, and now we can plug in this value right there. So 2 minus 1 over 2 plus 2, that gives us a value 1/4, and that is the limit when x approaches 2. All right, now for this next one, instead of factoring out, we can multiply by a conjugate. So it's basically like a reverse operation of the previous problem we just did. So we're going to multiply this by the square root of x plus 5 over the square root of x plus 5. And we're going to get x minus 25 over x minus 25 times x plus 5, the square root of x plus 5. So now we can cancel these x minus 25s out, leaving us with 1 over the square root of x plus 5. Now, limit as x approaches 25, once again, we're going to have the square root of 25 plus 5, which is just 1/10. Okay, for the next one, same conjugate. we're going to do the same thing. Square root of x plus 2 plus the square root of 2 over the square root of x plus 2. So these cancel out. All right. So this will get us x plus 2 minus 2. These cancel out over x times the square root of x plus 2 plus the square root of 2. So now we have an x over x. You can cancel these out too. This leads us to 1 over x plus 2, the square root of x plus 2 plus the square root of 2. Now we can plug in, once again, as limit x approaches 0, 1 over 0 plus 2 plus the square root of 2. This leads us to get us 1 over 2 times the square root of 2. And that's the limit. All right, now let's go to the next slide on horizontal asymptotes. So a horizontal asymptote is basically when the graph approaches negative or positive infinity. And in order to find these, we want to use a specific trick. So what do we know for this trick? So we know that the limit as x approaches positive or negative infinity of 1 over x, or any sort of function that has x in the denominator, will approach 0. So as you see from this graph, what I drew, this is 1 over x. We see that as this graph approaches positive infinity, it's going to be approaching the value 0, but not quite touching it. That still means the limit is 0. And the same way on this side, as it approaches negative infinity, the graph is still going to be 0. So keeping that in mind, what I'm going to do is basically make this function similar in this next practice problem. So for this one, limit as x approaches infinity over this function, I'm going to find the highest degree of the denominator. In this case, it's 3, and multiply it by 1 over x over 3, which is the highest degree. And I'm going to do that both in denominator and numerator. This ultimately gives me 3 over x plus 4 over x squared plus 2 over x cubed over 4 plus 2 over x squared plus 1 over x to the power of 3. And so now, since we've used this identity, we're gonna basically make all these values 0, 0, all of these 0, besides this 4 because it's not over an x. So this will lead us to 0 plus 0 plus 0 over 4 plus 0 plus 0. That still makes the limit 0, but it's a way to do it. So the horizontal asymptote for this function would be 0. And yes, so let's practice this a little more. For the next one, once again, multiply by the highest degree in the denominator. That's a squared, 1 over x squared over 1 over x squared. So we're going to get 3x plus 2 over x squared over 1 plus 5 over x plus 6 over x squared. And now we're going to plug in this limit, which gives us infinity plus 0 plus 1 plus 0 plus 0. And infinity over 1 is just infinity. So the asymptote for this function would be infinity. And let's practice one more time. Highest degree is squared, so multiply 1 over x squared over 1 over x squared. This is going to give us 2 plus 4 over x plus 1 over x squared over 8 plus 6 over x plus 2 over x squared. And so once again, put in this value, no matter negative infinity, positive infinity, these values are still going to be 0. So we're going to have 2 plus 0 plus 0 over 8 plus 0 plus 0, which gives us 2 over 8. And simplify that to 1/4. So the asymptote for this function is 1/4. All right. So thank you guys for watching this video. I hope you learned a basic intro to limits, and there's still much more to learn for limits. Hopefully you enjoyed this video and learned something new. Thank you.